Hello students, how are you? Hope you are well in this lockdown situation, and also I think you are studying well, but actually we are not getting the feedback, the required feedback from you. What is required for us, that how you are learning, or how our study materials and videos are helping you. You are remaining silent also in our WhatsApp question answer session. So I think it is required. You have to also give the feedback to us, and also do the questions, and also if you have any doubts, then you have to clear those from us. Otherwise, you have to give the boards exam. Whatever the lockdown situation is going on, it will end somehow. We hope that it will end somehow at month of September, October, or at the end of the year. And you have to give the boards exam anyhow. You have to give. So obviously you have to be prepared for that one. It is the landmark exam for you in your life. And if you score less marks in that exam, so obviously you have to stagger in each and every moment in your life. So my suggestion is just take the study seriously, give your best to your study, and obviously you can do the better for your exam, better preparation for your exam. So let us today discuss about the trigonometric identities. Actually in the trigonometry chapter, 4 parts are there. The first part is the trigonometric ratios, second is the particular angles, third is the complementary angles, fourth is the trigonometric identities, and after that the application of the trigonometry, the height and distance is coming. So among those 5 parts, if I take that also application also in this part, so among those 5 parts, the trigonometric identities and height and distance is quite problematic. Actually not hard. It is not at all hard, but it is those are quite problematic. The remaining 3 parts are very much easy. You can do anyhow you can do those. Very easy parts are those. So let us just discuss about the trigonometric identities today. Actually I have seen in lots of exams also, and previous year students also, they feel trigonometric identity is very much hard. Actually here the proofs are there, that is you have to prove the LHS and RHS in this chapter. So whatever, actually here you have to go in a solid approach. So let us just discuss about the tips and tricks to solve those problems. Actually lots of problems are there. In your RS Agarwal book you will see more than 50 or 60 sums are there. So it is not possible for me to do all those sums in this short video class. So I will just give you some tips and tricks for those problems, to solve those problems, and I think it will help you much more to solve those problems. So let us start the tips and tricks, and also I will give some examples. I will solve some examples at the later part of this video. Okay, let us start. So students, in trigonometric identities chapter, the 90%, not 90%, actually 100% problems are like that. You have to prove the LHS equals to RHS. All are the proving problems. You have to prove those. No any evaluation, no any find the value, nothing are there. Just you have to prove some LHS equals to RHS. Now from where you will start? You can prove LHS from RHS, or you can prove RHS from LHS. No any problems are there. No any number will be cut down. But from where you have to start? You have to see the complexity of the, you have to compare the complexity of LHS and RHS. Complexity means here you have to check the number of terms, where the number of terms are more. then you have to check the number of operations, then if roots are there, the radical signs are there, root over cot theta, root over sine cube theta, if this type of things are there, and also simplified form. When you will see one problem, you can understand that which part is the more complex. So you have to start from that more complex part, you have to simplify that part. Sometimes directly, if you start from LHS, if LHS is the more complex part, sometimes directly the RHS will come. Otherwise, one simplified solution of LHS will come, and you have to solve that RHS also to get that simplified solution of the LHS. So it will be a little bit easier to you to compare those. Okay. Now, some tools and techniques are required for solving those problems. What are those tools? Whatever you have learned up to the the complementary angles, all of these, those trigonometric ratios, the values of the particular angles, the complementary angles, what are just changing, those, all of these are required. So I am writing the tools and techniques. At first, the T ratios, the values of T ratios and the quotient ratios, actually I am showing you later. T ratios, then values, actually in very less number of questions the values are required, but also you have to keep in mind, you have to memorize those values. I have told you to make a chart for those. I think you have done, but some of you have submitted also, but some of you have not submitted. Submit me at my WhatsApp group. So T ratios are there, and then the algebraic identities. Trigonometric identities, actually what is the application of this chapter is all about the application of the trigonometric identities. So trigonometric identities, T identities, and I have seen very often the rationalization technique, what you have learned in class 9, the first chapter, the real numbers chapter, remember it. So that in that chapter the rationalization technique was there. So that technique somehow very often it is being used here. Rationalization. So T ratios, you know what are the T ratios? Sine means perpendicular by hypotenuse, cos means base by hypotenuse, all of these T ratios. Those are required. Some of those are required, but mostly what are required? The quotient ratios. Quotient ratios of the T ratios. Quotient ratios, as for example, the tan theta. Tan theta means sin theta by cos theta. Tan theta means sin theta by cos theta. Cot theta means cos theta by sin theta. And also the opposites. Opposites means cosec theta means 1 by sin theta. Sec theta means 1 by cos theta. Like that. Those are required. Mean 99% sums, those are required. So you have to keep in mind, you have to memorize those formula very well. Algebraic identities, all the algebraic identities what you have learned from class 7, yes, it was in class 7 or from class 8. From class 8 up to class 10, whatever the algebraic identities you have learned. As for example, a plus b whole square, then a minus b whole square, a square plus b square, that is plus minus a square plus minus b cube, sorry, a cube plus minus b cube. Those lots of identities are there. That is the algebraic formula actually. And you have made the chart. I know in class 9 you have made the chart. So just go through those. All of those are required in this chapter. Mind it. And also not in this chapter. Throughout the life actually, your student life, wherever you will do the mathematics, in most of the times those are required. So you have to keep in mind all this. Trigonometric identities. Trigonometric identities, actually there are three main trigonometric identities. What are those? Number 1, sin square theta plus cos square theta equals to 1. Number 2, sec square theta equals to 1 plus tan square theta. And number 3, cosec square theta equals to 1 plus cot square theta. Those are three main trigonometric identities what will be used often to solve the questions of this chapter. Now, sometimes those will be directly used. Sometimes their conclusions, their derivations will be used actually. That is sin square theta plus cos square theta equals to 1. From here you can see, we can write sin square theta equals to 1 minus cos square theta, or the opposite one, cos square theta equals to 1 minus sin square theta. In same thing here, sec square theta plus 1 plus tan square theta equals to this is the main part. So from here we can say tan square theta equals to sec square theta minus 1. Or we can say sec square theta minus tan square theta equals to 1. Actually, what are the from those main three trigonometric identities, whatever the conclusions or whatever the corollaries we can find, those will be used here. So you have to keep in mind. And the rationalization process. Rationalization process, you know, that is somehow in the denominator, if sin theta minus cos theta is there, so obviously you have to multiply both the numerator and the denominator with sin theta plus cos theta, actually the opposite sign of this. You know all of these. Those tools and techniques are very much required for solving those the questions of trigonometric identities. So actually, according to my experience in my student life also, we have done those, our teachers has told us also, and I am saying you, I have seen in previous classes who have done the trigonometries, in most of the time those problems are solved by simplifying the ratios. That is, you have to convert all of the ratios, that is tan, cot, cosec, sec, except of sin and cos, all these into the form of sin and cos. What I am telling, that is except of sin theta and cos theta, whatever the trigonometric ratios are there, you have to more often, actually not in all those problems, but often you have to convert those ratios into the form of sin theta and cos theta. That is tan theta equals to sin theta by cos theta, cot theta equals to cos theta by sin theta, then sec theta equals to 1 by cos theta, cosec theta equals to 1 by sin theta. Those are the conversion. Actually, all those trigonometric ratios can be converted into the form of sin theta and cos theta. So, in most of the problems, you have to do those. If you find some complexity, that is nothing are coming out, in which way you will solve this sum, then you have to apply this method. You have to convert all of these into sin theta, in the form of sin theta and cos theta, and somehow something will be there, it will be more simplified, and you can find the solution of these questions. And the second part is that is problems, you have to take the commons. Suppose it is say cos square theta minus cos to the power 4 theta. In some steps or at the first of the question, it is like that, cos square theta minus cos to the power 4 theta. So here no any trigonometric identities are there, directly not anything is applied here. But if I just take the common here, cos square theta will be common from here, so 1 minus cos square theta. Just see, one trigonometric identity we have found, that is sin square theta plus cos square theta equals to 1. So 1 minus cos square theta, this cos square theta is coming at the right hand side, so 1 minus cos square theta, we can write sin square theta. I have seen one problem. This was just I have applied this rule. Just yesterday or day before yesterday, one student has given me one problem, and that in that problem I have used this one. So that's why I am saying, that is, you have to take the commons. Whenever directly no any trigonometric identities are being applied, you have to try to take the common. If some corollary or directly some trigonometric identities are coming, then you have to use that one. So those are some simple techniques. You have to memorize those techniques whenever you have to solve. Actually, most of the times you have to think, that is, most of the times the unknown problems will come in your exam. In trigonometric identities, lots of problems are there and lots of complex problems are there. Most of the problems are like that, you have to do in trial and error method also. Somehow you have gone at the last stage, and there you are seeing that in what approach you have done this problem, that was wrong. You have to think in another way, and also you have to cut all of this and then do in a fresh way. So those are very time consuming methods also. So to avoid this, you have to practice a lot those trigonometric identities problem, and also you have to develop your intuition. That is, you have to, whenever you are seeing some problem, then and there your eyes will say you something, that is, in this way if we approach, then we can solve this problem. So that's why you have to practice a lot. Without experience, those type of intuition will not come. So my suggestion is, practice a lot. In R.S. Agarwal, what the book you are following, lots of problems are there. In NCERT book also some problems are there. And if you want, you can follow the all-in-one book, Arihant all-in-one book, and other books are also. Now, I want to give you one pre-planned path. In that path, you will just approach towards the problem to solve the problem. Actually, here in trigonometric identities problem, each and somehow most of the problems are different from each other. In the path, the approach of the problem, the identities, what is being used here, you are doing in a long process, and here there are you have not seen, that is, there will be a small trick. Within that trick, you can do that sum in less time. So those are the smart thinking, and also you have to, I have told you, that is, you have to develop that intuition. Here I am giving you one pre-planned path. In that path, if you approach, 90% problem will be solved. So what is that path? That is actually a loop. I am writing here, that is identities. Conversion into sin theta in the terms of sin theta and cos theta. I have told you previously this one. Then use of algebraic formulae. Whatever the formulae I have told you, those. And next, rationalization. and again use of identities. This is a loop. Actually, I have seen you in one YouTube video. This type of loops they were doing, and also in that way we are solving that one. I got number 1, this is number 2, this is number 3, and this is number 4. Whenever you will see one problem is given over there, you have to compare the LHS and the RHS according to their complexity, which is more complex. From there you have to start the problem. Then you have to think that is directly any identities or corollary of the identities are being used there or not. If we can use the identities, then we have to use the identities. Otherwise, come to the next step, conversion in the terms of sin theta and cos theta. I have told in most of the questions, that is more than 90% questions, you will find the solution. It will be easy to break the cot theta, cosec theta, tan theta, those in the form of sin theta and cos theta. Then come to the use of algebraic formulae. Whenever those has been used, some simplified form has came. I will give you some examples for that one. So some simplified form has came. Then you have to think that whatever it is coming at that part also, you have to take the LCM of something, or you have to multiply something, or you have to do the directly the rationalization process. Actually, whatever it will come, it will based on the situation of the sum. You have to convert the sin theta in the sin theta and cos theta, and then you have to think about all of this, that in which way we have to go. So in most of the time we have seen that is you have to take the LCM and also something is coming, and then you have to use again the identities, or you have to come to use the algebraic formulae, that is a plus b whole square, or s common as b square, a square plus b square, a cube plus b cube, all those formulae will be there. And then at last the rationalization process. Somehow in some part of this solution, if the situation required, that is the rationalization. If you rationalize, then the identities can come, or directly it can be solved. The RHS can come, like that. Actually, you have to think. I have given a pre-planned path, that is in this path. If you just approach, then most of the times you will find the solution. But it is not actually uniform. Some exceptions are there, but in most of the times you can solve the problems with this pre-planned path.